Okay, so here I'm going to try to do a couple of different calculus examples with derivatives and integrals, doing some of the, I guess, more complicated rules, like the product rule, the quotient rule, and the chain rule for derivatives, and then we'll look at integrals also. So first example we're going to look at is x squared e to the x equals f of x. So we have f of x equals x squared e to the x. Okay, and this is going to be an example where you need to use the product rule, because if you remember, as we discussed in class, a product rule is going to be used when you can think of the function as being two functions multiplied together. And that's definitely what you have here, because you have x being squared, that's a function, and then you have e to the x, which is a function in itself, and you're multiplying those two functions together. So basically you have the example of a product rule here. Okay, so the way of thinking of this is something like, okay, if we're calling this f of x, let's say g of x is equal to e to the x, okay, and h of x is x squared. Okay, so if that's the case, those are the two functions that we're dealing with, and we're going to use the product rule. Okay, so when we do the product rule, we're going to take the derivative of the first function, so we'll take the derivative of h of x, which is 2x, and we're going to multiply that by the second function itself, which is e to the x, and then we're going to add to that the derivative of the second function. So the derivative of e to the x is e to the x, and times the first function. The first function is x squared, and that's equal to f prime of x. Okay, so again, the product rule basically break the function up into its different pieces, and then you're going to take the derivative of the first piece times the second function plus the derivative of the second piece times the first function, and that's equal to the derivative of the entire function f prime of x. So this is an example using product rule. Okay, the quotient rule would be used in the example where you have two functions that are being divided. Okay, so an example of this one would be something like e to the x over 1 plus x squared. So they have y equals e to the x over 1 plus x squared. Okay, so the first thing that we want to do is we want to identify what our two functions are. Okay, so we'll call f of x e to the x, and we'll call g of x 1 plus x squared. And we'll work with that. Okay, so with the quotient rule, we're going to take the derivative of the first function times the second function. The derivative of e to the x is e to the x. The second function is 1 plus x squared. We're going to subtract from that the first function times the derivative of the second. So we have e to the x times the derivative of 1 plus x squared, which the derivative of 1 is 0, and the derivative of x squared is 2x. So we have that. And then you have to divide the whole thing by the second function squared. So 1 plus x squared, the quantity squared. And then we'd have to clean all this up algebraically. Okay. So basically the denominator is going to be x to the fourth plus 2x squared plus 1. And the numerator doesn't look like we can do a whole lot with it. Let's see what we can write here. We have e to the x plus x squared e to the x minus e to the x times 2x, 2x e to the x. So that's all you're going to get there, over, what did we say, x to the fourth plus 2 times x squared plus 1. And that's our answer for y prime using the quotient rule. Okay. The chain rule is another rule that we would use, and we use the chain rule when we have what I call a function within a function, or nested functions. Okay, so you have something being done to the variable by a function, and then whatever that value is now being put into another function. So something like this one says ln natural log of cosine of x, or cosine of theta, I guess they use in this one, is equal to f of theta. Okay, so this is our function. Now you can see it's basically like two functions in one. You have the cosine function is one function, and then you're taking the natural log of that. Okay, so again, I like to break this up into two things. Okay, I'm going to call u of theta is cosine of theta. Okay, so something's being done to theta, we're taking the cosine of it. That's the first function. And then the second function, we'll call it f of u, because we're taking the value of u and plugging it in. And that's the natural log of u. Okay, and then the chain rule says take the derivative of u of theta and multiply that by the derivative of f of u, but make sure you make the substitution of u of theta equals cosine theta in. Okay, so the derivative of cosine of theta is negative sine theta. And the derivative of ln of u, the natural log of u, is 1 over u. But remember, u is cosine of theta. So we have 1 over cosine of theta times negative sine of theta. That's the same thing as negative sine theta over cosine theta, which is negative tangent theta if you remember your trig functions. So these are all examples of taking derivatives using calculus rules.